And there we go. So we're going to be using properties of exponents, but what we're going to do today, we're switching gears a little bit. Instead of just simplifying expressions, we're going to be solving equations, okay? This is a radical equation. You look at this, what's your indication that it's a radical equation? What do you see? You see a radical, and what else do you see? An equal sign. So you guys are on top of this. A radical equation. It has a radical, and it's an equation. It has an equal sign. The strategy here is when I see something like square root of x plus 1 or anything like that, I really don't like the square root. I want to get the x plus 1 by itself. What can I do to a square root to get rid of it? You square it. So because it's an equation, I can square both sides of the equation. Okay? Now, if this were not an equation, if I just had something like this, you know, well, if I had this, I can't just say, oh, to simplify this, let's just square it, okay? Because what am I doing? I'm changing what is there, okay? But if I square both sides of the equation, I'm okay. I'm doing the same thing to both sides. What happens when I square the square root of x plus 1? What do I get? X plus 1. What do I get on the right side? 16, okay? This is a linear equation, okay? This is a nonlinear equation. Which of these equations looks easier to solve? The squared one, okay? What does x equal? 15, okay? That's the solution to this guy. Now, you want to get in the habit of checking your answer, okay? This one's going to work out, but let's just check our answer. Let's check 15 plus 1. What's 15 plus 1? 16. What's the square root of 16? 4. Does 4 equal 4? All day long. So that answer is correct, okay? X equal 15 is a correct solution, and I verified that it worked, okay? Now, what is happening here? Now, I'm going to show you a graph, and this is not going to be something you're tested on, but when you get into pre-calc, you're going to do a lot more graphing than we do in here of these nonlinear functions. Here was my original equation, okay? Let's set it equal to 0. That means subtracting 4 from both sides. And now let's graph this function, the square root of x plus 1 minus 4. So this is beyond the scope of you graphing on a pen and paper right now, but it's the blue graph that you see right here, okay? And you can see it has 1, 0, or x-intercept at 15, 0. We just found the solution to be 15, okay? Now, when I square both sides of the equation, I get a linear function. This is just x plus 1 minus 16, or x minus 15. When I graph that, I get a straight line, okay? And it also has that same 0 point, okay? So this illustrates a powerful but yet sometimes simple concept in math, is that this equation is hard to solve, but when I square both sides, I have transformed it into an equation that's easy to solve. So I've taken a nonlinear equation, by squaring it, I made it a linear equation. Linear equation, much easier to solve, okay? So let's take another few examples of this. Let's look at this one. X plus 4 equal the square root of x plus 10. What is it that I need to disappear to make this problem easier to solve? The square root of x plus 10, I need that to be x plus 10. What could I do to both sides? I could square both sides, okay? Now, this one's going to be a little bit harder than the last one. Why is it going to be a little bit harder? Yeah, on the left side, I don't have a nice number like 16. So on the left side, I'm going to have x plus 4 squared. What will I have on the right side? X what? What happens when I square the square root of x plus 10? It's just what? X plus 10. All right? So I got something nice and simple on the right side, okay? Now, I don't have a linear equation. I have what kind of equation? Starts with a Q. Quadratic. You guys are experts at that from last semester, right? So I've got a quadratic equation that I need to solve. Now, never ever be tempted to say that this is x squared plus 16. Does everyone see why that's not the case? This is x plus 4 times x plus 4. Okay. How do I figure out what x plus 4 times x plus 4 is? What do I do? You FOIL that. So this is x squared plus 4x plus 4x plus 16 equal x plus 10, or x squared plus 8x plus 16 equal x plus 10. Okay, that's a quadratic. I don't like to solve quadratics equal to x plus 10. I like to solve quadratics equal to 0. How can I get this as a quadratic equal to 0? Yeah, subtract x and subtract 10. Okay. When I do that, I get x squared. How many x's will I have? This is where you would interact with the teacher and say, 8x minus x is, come on guys, 7x, right? And then what? Plus 6 equals 0. Now I have a quadratic equal to 0. You have a number of ways to solve this. Your favorite being the quadratic formula, is that right? Or least favorite? That is your least favorite? Yes. No, you cannot combine x cubed and x. They're not alike. You can't. X cubed minus x is just x cubed minus x. It's, well, x cubed minus x. You can factor an x out. It's this. But you can't add them together. You can't combine them. You can only combine things that are identical when you're adding and subtracting. Okay, guys, how do I want to solve this quadratic? What's the way that I love to solve it? If it works, I love it. It's what? Starts with an F. Factoring. If I can find two numbers that do what? Multiply to 6 and add to 7, I will be in business. Are there numbers that do that? 1 and 6. So what is the factorization of this? X plus 1, x plus 6 equals 0. That means that x is equal to what? Yeah. Okay. Now, you want to get in the habit of doing what when you get those answers? Check your answers. So I'm going to check -1 and -6. I'm going to check those in my original equation. So my original equation was what? X plus 4, x plus 10. So I've got x plus 4. I'm going to plug in a -1 here, okay? So let's just do that. -1 plus 4 equal the square root of -1 plus 10. Just plug in a -1. What is 4 minus 1? 3. What's 10 minus 1? So the square root of 9. What's the square root of 9? Does 3 equal 3? Yes, so I'm good. Okay, that means this solution is valid. Now let's check the same thing with a -6. So I've got x plus 4 equal the square root of x plus 10. So now I'm going to plug in a -6 in both places. What's -6 plus 4? That's -2. What's 10 minus 6? 4. So the square root of 4. Does -2 equal 2? No. What does that mean? This is what? No solution. That's not a solution. So the only solution is x equal -1 is the only solution. Okay? So you need to validate the answers you get when you do something like squaring both sides of an equation. Now what this represents, and again, this is a little bit more complicated than what you're going to go into, but I just want to show you what happened. This was our original equation, okay? When I graph it, I get this blue line, and it only crosses the axis at one spot, -1. But when I squared both sides, I got a quadratic. Another word for the graph of a quadratic is a what? Parabola. when I graph this parabola, it crosses the axis how many times? Twice. So I got -1 and -6. That solves the quadratic equation, but both of these numbers don't solve the nonlinear or radical equation. So when I got two solutions to the quadratic, I have to say, let me go back and check and see if they both work for my original equation. And I found that one of them only worked for the original. So I can't give you a formula. When you get two answers like this, when you square both sides, you get an answer, you're going to have to check and make sure they're valid in the original. Because what we're doing, we're transforming the equation. So we're getting solutions to the transformed equation that may not be solutions to the original equation. The only way to do it is to go back and check those answers. Yes, Jack? The quadratic does. Right here. So when we solved that quadratic, we found x is -1 and -6. But when we plugged it into the original equation, only the -1 worked, okay? And so this is graphically showing that to you, which is sort of beyond the scope of what we're doing, certainly for the test that's coming up. But I just want to show you what was happening. So what this is called is an extraneous solution. So when you do something like square both sides or cube both sides, it's valid what you're doing, but you're transforming the equation. And so the solution to the transformed equation is not always the solution to the original equation. The only way to do it is to check your answers. So let's take a look at another couple of examples. Now this one's different. X minus 8 to the 5th minus 32 equals 0. Now, what do I want to get by itself? The x minus, well, ultimately x, but I want to get the x minus 8 to the 5th all by itself to begin with. How can I do that? I'll do that in just a minute. You guys are ahead of me. I just wanted to do this first. X minus 8 to the 5th equal 32. Okay? Now, what I want is this x minus 8 to the 5th, I want it to be x minus 8 to the what? To the 1st. Okay? What power can I raise everything to make that happen? To the 1/5 power. Okay? A moment I had square roots. That's the 1/2 power, and I squared it. Okay, so what you do is, whatever this is, you look at its what? What is the relation between 5 and 1/5? They are what to each other? Reciprocals. Okay, so if I raise everything to the 1/5, so what is, when I raise something to the 5th and the 1/5, I multiply those exponents. What happens when you multiply 5 and 1/5? What do you get? You get 1. So this turns into x minus 8 equal 32 to the 1/5. So when I take everything to the 1/5 power, that's what I get. Now, what does it mean to have 32 to the 1/5? That means the 5th root of 32, which is 2. So my answer is x minus 8 equals 2. X is equal to what? So x is equal to 8 plus 2, or x equal 10. Now you just want to stay in the habit of checking your answer. I can do this one in my head, or do I need to write it down? Write it down or in my head? Okay, we'll write it down. So 10 minus 8 to the 5th minus 32. What's 10 minus 8? 2. What's 2 to the 5th? 32. So what's 32 minus 32? That is 0. That is a true statement. So x equal 10 is the solution to this equation. Yes? Okay, let's continue on. Cube root of 2x plus 7 equal 3. I don't want the cube root of 2x plus 7. I really just wanted 2x plus 7. Okay, so what would I need to do to both sides of this equation? Cube them. Okay, so I will need to cube both sides of this equation. So once I've got the expression that's to this cube root on one side, then I can cube both sides. What do I get on the left? 2x plus 7. That was by design. What do I get on the right? Yeah, 3 cubed, which is 27. So then I get 2x is equal to 20, so x is equal to 10, just like the last problem. Okay? And if I want to check that answer, so let's check 10. So what is 2 times 10 plus 7? What's 2 times 10? 20. 20 plus 7 is 27. Cube root of 27 is 3. So this says that 3 equals 3, which is true on most days of the week, right? So there we go. So x is 10 is the solution to this problem. So again, what you want to do, you want to look at whatever variable expression you have that is nonlinear, get it by itself, and then take care of it. So now if you look at this, on the left side, I've got an expression that's not linear. What would I have to do to make it linear? Well, no, I mean, it's a square root. To make it linear, I need to square it, okay? So on this equation, I would do what to both sides? Square both sides of this equation. Okay, that will make the square root go away on the right. So on the left, I get x plus 1 squared, right? What do I get on the right? 7x plus 15. This is what kind of equation? Quadratic. You know how to solve quadratics, okay? So let's FOIL the left side. So x plus 1 times x plus 1 equals 7x plus 15. So this is x squared plus 2x plus 1 equals 7x plus 15. And then what do I do to get this solved? I like it to be equal to what? 0. I can do that by doing what? Subtracting 7x and 15 from both sides. So x squared, what's 2x minus 7x? Yeah, minus 5x. And then what's 1 minus 15? Yeah. That will solve if I can find two numbers that do what? Yeah, multiply to negative 14 and add to what? Negative 5. What numbers multiply to negative 14 and add to negative 5? Negative 7, positive 2. So that means the factorization is what? Yeah, x minus 7, x plus 2. Therefore, x is equal to what? 7 or negative 2. But I'm not good to leave the answer there because I have to do what? I have to check the answer. So I'm going to check 7 and negative 2, okay, in the original equation. So my original equation was x plus 1 equals square root of 7x plus 15. So I'm going to plug in a 7 for x. So 7 plus 1 equals square root of 7 times 7 plus 15. So 8 is equal to, what's 7 times 7? 49. 49 plus 15 is 64. So this is the square root of 64. What's the square root of 64? That's 8. 8 equals 8. Is that true? Yes. Okay. Let's check negative 2. So negative 2 plus 1 equals 7 times negative 2 plus 15. What's 7 times negative 2? Negative 14. Negative 14 plus 15 is? Negative 14 plus 15 is 1. Square root of 1 is 1. Okay. Negative 2 plus 1 is negative 1. Does negative 1 equal 1? No. So what does this mean? Yeah. So the only solution is what? X equals 7 is the only solution, okay? So this is how you handle those extraneous roots. There's no way of knowing other than just checking your answer, okay? When you have done something like square both sides of the equation and you get two answers, you are not guaranteed either of them works, both of them works, one of them works, okay? So you're going to have to check it to make sure. So this one, in order to solve it, what do I want to be by itself before I do anything to both sides? Yeah. In checking the answer, or? Right here? 7 times negative 2 is negative 14. Negative 14 plus 15 is 1. Negative 14 plus 15 is 1. The square root of 1 is 1. So in the next one, what is it that I need by itself before I can do anything to both sides? What needs to be by itself? Before I raise to powers, what needs to be by itself? X plus 2 to the 3/4. Because if I were to try to raise it to a power now, I get something real complicated, okay? I want that to be by itself. So what can I do to get it by itself? Add 1 to both sides. So x plus 2 to the 3/4 equal what? 8. Now, what power do I need to raise this equation to so that that x plus 2 is to the first power? To the 4/3. That's the reciprocal. So I need to raise this to the 4/3 power. What do I get on the left side? X plus 2 equal 8 to the 4/3. Now, what does 8 to the 4/3 mean? We've done this before. That means the cube root of 8 to the 4th. What's the cube root of 8? 2. What's 2 to the 4th? 16. So this says that x plus 2 equals 16, which means that x is equal to what? X is 14. Now I can check my answer. If I plug in a 14 here, what's 14 plus 2? Come on, guys. 14 plus 2? 16. What's the 4th root of 16? 2. What's 2 cubed? 2 cubed is 8. What's 8 minus 1? 7. This works, okay? So I did that in my head, but you can write all of that down. This is a valid solution, okay? I want to do this one, and then I'm going to skip one and move ahead. So let's look at this. What needs to be by itself here? Yeah, so I can write this as x plus 4 equal negative 10, okay? Excuse me, square root, okay? Now, to solve this, what I'm going to do to both sides of this equation? Do what? Square both sides of the equation. What do I get on the left? Yeah, so x plus 4. What's negative 10 squared? It's what? 100? Okay. So x plus 4 equal 100. What does x equal? Yeah, x equal 96. Now let's go check this answer. So the square root of 96 plus 4 plus 10 equals 0. What's 96 plus 4? 100. Square root of 100 is 10. Does 10 plus 10 equal 0? No. What does that mean? This is what? This is not a solution. Therefore, there is what? No solution. Okay. So this one has.
Why wouldn't you take negative 10 as a square root? Because technically,
Pardon me?
negative 10 times negative 10 is 100.
Right.
So why couldn't you do like negative?
Well, if I put in a negative 10, negative 10 plus 4, this is negative 6. Square root of negative 6 is not equal to negative 10. Okay. So in this one, in the case of real numbers, this is saying you take the square root of a number and you get negative 10. Is there a real number that you can take its square root and get negative 10? There's not. Okay. So this one would have complex solutions, but we're not going to get into for this specific problem. Okay. So this is why you want to be in the habit of checking the answers. I'm going to skip the next one, not because it's not important, but I need to move on. But what would I do to both sides of this equation? You do what? You would raise it to the third power, okay? And you could get to the solution of that. Now, all the problems we had so far, I had exponents that were mainly odd exponents. And I need to move on to a concept we've seen before, just make sure that we know. We solved this problem last semester when we solved quadratics. Remember, we did factoring, we did square roots, we did quadratic formula, okay? Now, in order to solve this, what did I do last semester to solve this guy? I take the square root of both sides, okay? The square root of x plus 1 squared is what? X plus 1. I wrote an equal, and there was a big memo that went in your head. What was the next thing I wrote? Plus or minus, okay? X plus 1 equal plus or minus square root of 16. What's the square root of 16? 4. So x plus 1 equal plus or minus 4. X equal negative 1 plus or minus 4. What's negative 1 plus 4? 3. What's negative 1 minus 4? Negative 5, okay? So there are two solutions to this problem. So anytime you have an even exponent, okay, when you take the square root of something to an even exponent, your answer will have a what? Plus or minus in it, okay? So let's take another example of that over here. Now what I see here, x minus 2 to the 4th minus 1 equal 15. What do I want to get by itself? Yeah, x minus 2 to the 4th. I can do that by adding 1 to both sides. So x minus 2 to the 4th equals 16. Okay. Now what we did last semester, it would have looked like x minus 2 squared. But because this is an even exponent, when I take the 4th root of both sides, I'm going to have plus or minus in my answer. Okay. So I'm going to take the 4th root of all of this. Okay. So what's the 4th root of x minus 2 to the 4th? Yeah, x minus 2 equal. Bells in your head tell you to write what next? Plus or minus the 4th root of 16. What is the 4th root of 16? It is 2, because 2 to the 4th is 16. So x minus 2 equal plus or minus 2. If I add 2 to both sides, I get x is equal to 2 plus or minus 2. What is 2 plus 2? 4. 2 minus 2? 0. Okay. So 4 and 0 are the two solutions to this. So what you're doing here, you're bringing the knowledge that when you see an even root, there will be two answers. Okay. So you're not transforming this equation. You're looking at it and say, okay, because that's an even root, I know there are two solutions. You're bringing that knowledge to bear. If you didn't do that, then you're only going to get half the answer. Okay. So keep in mind, when you square both sides of an equation, you could introduce roots, or cubing or fourthing both sides of an equation. But when you have a solution that has an even root, then you need to know there are two solutions to that. Now, what you haven't seen before, and it still works with fractional exponents, is what you see here. 2/3, I've got x plus 1 to the 2/3. 2/3 is a fraction, so it's not an even integer. But what you need to look here is look at the numerator. The numerator is a 2. Is that even or odd? 2 is what? Even. When I see an even exponent here, or an even exponent as the numerator, I will have a plus or minus as my answer. Okay? Because what does this mean? This means the cube root of something, and then what? Square it. So when you square something, Squaring 4 is the same as squaring negative 4, right? So when you square it, you take out that dependency on it being plus or minus. That's why you get the two answers. So now, if I look at this next one here, x plus 1 to the 2/3 equal 9. What power will I raise this to in order to solve it? To the 3/2 power. And I need to keep in mind that that is an even exponent. So what's x plus 1 to the 2/3 to the 3/2? What's that? X plus 1, right? That was by design. Okay, I want the x plus 1 to be by itself. So x plus 1 equal, because that's an even number in the numerator, the very next thing I write will be plus or minus, and then 9 to the 3/2. What does 9 to the 3/2 mean? It means the what? Square root of 9 cubed. What's the square root of 9? 3. What's 3 cubed? 27. So this says that x plus 1 equal plus or minus 27. X equals negative 1 plus or minus 27. So x is equal to what? Negative 28 or what? Or 26. Those are my two solutions. Okay? So anytime you see an expression raised to an even exponent, you'll have an answer with a plus or minus. That also extends to when you see an even number in the numerator of that expression. You'll also have a plus or minus in your answer. And that's just knowledge you need to bring to that equation. Okay? It's not going to happen for you in the course of solving it without you knowing that. Now this one, pardon me? Sure. Okay, let's look at a couple more. I know we're pushing hard, and I don't really like these 45-minute classes for this. X plus 9 to the 6 is negative 64. That's raised to what kind of exponent? Even, right? I will have a what? Plus or minus in my answer, okay? So I'm going to have x plus 9 to the 6 equal negative 64. What power am I going to raise everything to? To the 1/6, okay? What do I get on the left side of that equation? X plus 9. So x plus 9 equal, what is the next thing I will write? What? Plus or minus, because I have an even exponent. And now I got to figure out what is negative 64 to the 1/6, okay? So I got to figure that out. So let's look at it this way. This is, I'll do it right down here. Negative 64 to the 1/6. That's negative 1 times 64. So all of that to the 1/6, okay? Everyone agree with that? So negative 64 to the 1/6, okay? So that's negative 1 times 64, all of that to the 1/6. So this is negative 1 to the 1/6 and 64 to the 1/6. What does 64 to the 1/6 mean? The 6th root of 64, which is what? 2, because 2 to the 6 is 64. So this is negative 1 to the 6 times 2. Now I just got to figure out what is the 6th root of negative 1. What kind of numbers are it going to be? Anybody? Real or complex? Complex, okay? It's just like, when you had the square root of negative 1 was I, it's going to be something like that. So let's just figure this out. So this is negative 1 instead of writing it as negative 1 to the 1/6, I'm going to write it as negative 1 to the 1/3, the 1/2. Everyone see that's the same thing, right? 1/3 times 1/2 is the same as 1/6. That's a 1/6, okay? So what is the cube root of negative 1? Cube root of negative 1 is negative 1 because negative 1 times negative 1 times negative 1 is negative 1. So the cube root of negative 1 is just negative 1. So this is negative 1 to the 1/2 times 2. What does raising to the 1/2 means what? What does it mean? To the 1/2 is what? Square root. What's the square root of negative 1? I. So this is, you guys act like it's defeat. Yes. So the cube root of negative 1 is negative 1. So now I've got to take the square root. The square root of negative 1 is I. So this answer is x plus 9 equal plus or minus 2i. X is negative 9 plus or minus 2i. This is as hard as these get, okay? This one is out there, but you've done this stuff before, okay? Properties of exponents, properties of complex numbers. You're good with that. The next one's a little bit more straightforward. The key here, when you look at this, always look and say, is that even? If that's even, your answer has a plus or minus. My answer had a plus or minus. When you look at this, you ask yourself, is that even? Is that even? Yes, my answer will have what? Plus or minus. So what power do I raise this one to? To the 3/2? What do I get on the left side? X equal, what is the next thing I will write? Plus or minus. And then it's negative 9 to the 3/2. So what does that mean? It means the square root of negative 9. What's the square root of negative 9? It's 3i. So this is x equal plus or minus 3i cubed. Okay? 3i cubed. What is 3 cubed? 27. So x equal plus or minus 27. What is I cubed? Negative I. Now here's something. If I've got plus or minus negative 2, what does that really mean? I mean, what is that? Plus or minus a negative number. Does that change anything? Plus or minus 2 is the same as plus or minus negative 2. Do you agree with that? So this is just plus or minus 27i. I would take either of those, any of those as an answer, okay? So these are a little bit more difficult because they bring back this complex number. The key to what we did today is always look and see what the exponent is. Even exponents, you're going to have plus or minus in your answer. If this number is positive, good, you got real numbers. If that number is negative, you're going to have what kind of numbers? Complex, okay? Where? Right here? So you're good to here, right? So 3i cubed. 3 cubed is 27. I cubed is, that's I squared times I, which is negative I. So plus or minus 27 times negative I. Okay, guys, I know we did a lot today. Spend time with the homework tonight. I will see you again tomorrow. We'll wrap up this unit and be ready for our review.